Hello and welcome to this Getting Started tutorial on how to use the CoreProfiler application. I'd like to take this opportunity to acknowledge ACARP for their support of this project. Today I'm going to show you how to build a depth-scaled core image from imported core tray photographs. You can use standard off-the-shelf consumer cameras for this purpose. For best results when taking photographs, you should be stood directly over the tray or split and try to fill as much of the frame as possible into the photograph. As you can see, the CoreProfiler application has been opened and I can create a new project by pressing the new toolbar button. This option is also available from the File menu. As you can see, an empty project has been created called borehole1.cpr, and this is the name that we're given to the file. The details of the project are shown in the Properties window, and you can define things such as the borehole name. The next step is to use the wizard to import some core tray photographs to create a scaled image from. There are some example core tray photographs in the Tutorials folder in the Install directory. Click on the camera or under the Build menu to add core photographs. Alternatively, you can right click on the name of the project. For this tutorial I'm just going to select two core trays, box 3 and box 4. This opens the Add Core Photograph wizard. Click Next to proceed. This page of the wizard is used to define the parameters of a core tray or split. Here I can define the width and height of the core box, the number of rows of core in the core box, and any gap that would exist between each row in the tray. In this instance there isn't really a gap. The size of this tray is about 98 centimeters, so I'll put in 0.98, and the height is 37 centimeters, so I'll put in 0.37 as it's measured in meters. If you're importing multiple core trays and they're the same size, clicking this box will apply these dimensions to every tray, and just click Next to proceed. This wizard page will correct the photographs for lens distortion. This is only applicable to higher end cameras such as some of the Nikons. For most people you can just ignore this page and proceed. Now we will select the four corners of the tray to extract the image. As you can see, there's a zoom window to show us easier navigation to the corners of the tray. Once the four corners are selected, the image will be rectified and the result will be showed here. So you can reselect points if you're not happy with the selection. Then click Next to choose the next tray. We just repeat for this tray, selecting the four corners. That's all there is to importing core tray photographs. As you can see, the core tray photographs have been imported into the project, and we can select the core trays here. If they're out of sync, you can easily drag the core trays to put them in the correct order. It's best to name your core photographs so that you can know the order in which to put them. Again, clicking on each tray will show you properties about the tray in this window, such as the size of the tray, the number of rows. The next step is to actually annotate the core so that we can build a scaled core image. We do that by splitting the core into sections. Let's start with the first tray. Each tray already has a section of core defined. If you click in here, it'll give you give information about each section of core. There are handles at the end of each section so that you can resize the section of core. We can see down here there's actually part of the tray where there isn't any core, so we just drag the handle so it ignores that part of the tray. We'll repeat that for the next photograph. Also notice that there are broken sections of core, for instance here, and this will affect the scaling of the core. So what we can do is we can split this into further sections and define these sections as broken, and then the scaling will be applied to the broken section of core. To do this, you can just add extra core breaks into the core. Go to the properties, and rather than being continuous, define it as a broken section of core. This will be highlighted in red as a visual indicator that this is broken core. We'll repeat this for the other broken sections. Also notice on this tray we have a sample interval to specify there's some core missing. So we can apply a sample interval to this part of the core. A sample interval is highlighted in yellow, and we can give it a from and to depth to define the missing section of core, and also we can give it a name to identify it. In this case it says gas bombs. And the start depth is 47 metres. For now I'm going to omit the to depth. Also notice that there's core breaks or core blocks that define a depth interval of core where you can apply that. It will be shaded and highlighted in blue. Let's try and build our core tray. Also notice that you can apply core blocks. These are depth markers, similar to a sample interval, and you can just define a fixed depth that the software will use to scale the core. Okay, I'm happy with how we've annotated our core. Let's now try and build the core itself. Build the scaled image using this button, and again available from the menu option, Build Borehole. The status information is output to a process log down at the bottom here, so you've got an indication of where any errors occurred. As you can see, it says that box 3 must have an initial interval defined. It's mandatory that the first section of core has to have a start depth, so we know where to scale the core from. In this instance, the start depth is 39.3 metres, so we select the first section of core and define the start depth as 39.3 metres. I then try and rebuild the core again. Now we have a different failure on box 4, and it says that the sample interval is undefined. Remember earlier we only defined the from depth? Well, now let's define the to depth. That's 51.3 metres and rebuild. That's better. The core has successfully built and a preview window has appeared. Click on the preview window to see the scaled core. Let's have a look at our core image. As you can see, there's some red bands along the core. These indicate that the core is needed to be scaled by more than 10%. In this instance, this section of core here was scaled by a factor of 1.3, and this core also by 1.3. This just serves as a warning to double check what you're doing. If you get this across all your core, perhaps you entered your core tray dimensions incorrectly, or entered some of the depth markers or sample intervals or the start depth of the core incorrectly. Let's see what happens with our missing core between 47 and 51 meters. As you can see, the core is missing between 47, and our gas bombs identifiers marked on the core. You can use the file export borehole image option to export the scaled core image as JPEG or other standard formats so that it can be imported into third-party packages such as Geolog. If you're happy with the result, you can also save your project using the Save option on the menu. Thanks for taking the time to watch this video about CoreProfiler. There's far more to CoreProfiler, and in the next tutorial I'll show you how to create a digital log sheets and to calculate the angle to core axis.